Assalamualaikum and hi, my name is ALEEYA binti RAMDZAN and my matric number is 059366. Today, our group will present about the digital fluoroscopy, luminous lotus mag model by Siemens Healthineers. Fluoroscopy is a type of medical imaging that shows a continuous X-ray image on a monitor, much like an X-ray movie. Fluoroscopy may be performed to evaluate specific areas of the body, including the bone, muscles, and joints, as well as a solid organ such as heart, lungs, or kidney. Photography shows an ALEEYA fluoroscopic in 1933 system in use before the development of image intensification. An actual fluoroscopic examination with this device would have occurred in darkened room. There are three purposes of fluoroscopy. Firstly, fluoroscopy is done to evaluate the condition of the coronary arteries during cardiac catheterization. Secondly, to evaluate blood flow through an artery during angiography. And thirdly, to guide some diagnostic and surgical procedures such as the placement of the catheter during angiography, the insertion of a needle for biopsy, and the removal of fluid from a body cavity. For your information, fluoroscopy can deliver more radiation than common radiography, so the exposure rate must be kept very much lower. Since Siemens Healthineers has debuting its new fluoroscopic system, the luminous lotus mags, at the annual French GFR 2020, the system offers industry-leading technology in radiography and fluoroscopy. So, we decided to choose luminous lotus mags in our presentation because it is the latest model of fluoroscopy by Siemens Healthineers. Vice President of X-ray Product at Siemens Healthineers, North America, Naira Patel said the luminous lotus mag features a high level of integration that overcome challenges facing previous fluoroscopy and radiography system to deliver efficient workflow and permit high system utilization for an uninterrupted flow in fluoroscopy and radiographic exam. The luminous lotus mag is a model by Siemens. It released date in November 2020. There are a few features of luminous lotus mags. First, it combines radiographic and fluoroscopy imaging with orthopedic studies such as long leg or full spine examination and basic intervention because radiographic and fluoroscopic capabilities are highly integrated and users can quickly switch between the two forms of imaging. Second, a premium 2-in-1 remote control imaging system that seamlessly integrates fluoroscopy and radiography for increased productivity and optimized clinical operation. Thirdly, it automatically encrypts all images and patient data. This encryption, combined with regular software updates and an elaborate role-based access control, helps ensure compliance with the highest cybersecurity standards. Last but not least, it also designed to be operated remotely from a control room.
Greetings, my name is EMILLIA ERON, metric number 060370. Today, I will be presenting about the advantages of Siemens Luminous Lotus Max and Shimadzu Fluorospeed X1 Edition. Firstly, Fluorospeed X1 Edition has antivirus software and security software as a standard feature, lowering the chance of cyber attack, while Luminous Lotus Max has a comprehensive cyber security system that provides a secure environment for all of sensitive patient data. It features a robust set of security features that can be customized to meet specific needs. Secondly, Fluorospeed X1 Edition has a removable grid for pediatric patients. It is further advantage in dose reduction, and it is important especially when the radiation exposure is a particular concern, such as pediatrics and gynecology. On the other hand, Luminous Lotus Max has MAX, which is multiple advances in X-ray, integrated detector in the system table. It's more than just a single features and functions. Multiple advances touching multiple aspects of work that can only be achieved when all system elements are seamlessly integrated in one network. We will get to experience MAX system with MAX Assistant and MAX Detection to achieve the best image quality in the shortest amount of time possible with the system. Thirdly, Fluorospeed X1 Edition has Score Pro Advanced, which is a system that can reduce background noise and improve the quality of fluoroscopic images in real time. It is also used for multi-purpose examinations. Luminous Lotus Max has a system called Diamond View Max. Radiographer can apply low dose and enjoy exceptionally sharp images with this system. This system is a unique image processing engine that delivers exceptionally sharp static and dynamic images with enhanced contrast, high level of detail visibility, and optimized noise reduction. Fourthly, Fluorospeed X1 Edition has high patient load for bariatric exam, which is up to 226 kg with 80 cm table width, and Luminous Lotus Max has a maximum table capacity, which is 300 kg and 80 cm table width. Lastly, the table for Fluoroscopy X1 edition is designed with a side touch sensor for patient safety, while Luminos Lotus Max table is designed with safety collision bumpers and smart touch to ensure a safe examination for those who need safety the most, which is the less mobile geriatric patients. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad SYAKIR and my metric number is 059596. Today I will present the basic principle of fluoroscopy. Fluoroscopy is the best method of real-time imaging and directly visible to the eye during an X-ray examination. During a fluoroscopy procedure, an X-ray beam is passed through the body. Then the image is transmitted to a monitor so the movement of a body part of contrast agent through the body can be seen in detail. So how does fluoroscopy works? Fluoroscopy function uses the same fundamental technology as projectional radiography. A typical fluoroscopy system consists in the following main components. X-ray tube. An X-ray tube is a vacuum that applies a high voltage to accelerate the electrons to leave from a hot cathode to extremely high velocity. This high-energy electron requires a metal anode to produce X-rays. The voltage of the X-ray tube and the material of the anode determine the energy of the resulting X-rays. Most of the anode is made up of tungsten and it's typically used to produce high-energy X-ray up to 150 kV. Collimator. This focuses the X-ray beam by allowing only X-rays traveling in a certain direction to pass through the patient. X-rays go through the patient and some of the radiation is absorbed. After the X-rays tube pass through the patient, the beam will strike the image detector or image intensifier. The X-ray image intensifier is an electronic device that converts the X-ray beam intensity pattern into a visible image suitable for capture by a video camera and displayed on a video display monitor. The main components of an X-ray image intensifier are an input phosphor layer, a photocathode, electron optics, and an output phosphor. The cesium iodide input phosphor converts the X-ray image into a visible light image. The photocathode is placed in close proximity to the input phosphor and it releases electrons in direct proportion to the visible light from the input phosphor that is incident on its surface. The electrons are stirred, accelerated, and multiplied in number by the electron optic components, and finally impined upon a surface coated with a phosphor material that glows visibly when struck by high-energy electrons, and that is the output phosphor of the X-ray image intensifier. There are two main components in the video display system, which are the TV camera tube and TV monitor. When TV monitors are used to display the fluoroscopy image, TV camera tubes are attached directly to the output phosphor of the image intensifier tube. Basically, a TV camera is used to convert visual information or image from the output phosphor screen of the image intensifier into electrical signals. Then, the video signal is amplified and transmitted to the TV monitor. The monitor has only two controls, which are contrast and brightness. For the TV camera tube, plumb beacon and Vidicon tubes are most often used. The last one is patient table and pad. Patient tables must provide strength to support patients and are rated by the manufacturer for a particular weight limit. The table must not absorb much radiation to avoid shadows, loss of signal, and loss of contrast in the image. Carbon fiber technology offers a good combination of high strength and minimal radiation absorption, making it an ideal table material. Foam pads are often placed between the patients and the table for added comfort, yet with minimal radiation absorption.
There are many maintenance of Luminos Lotus Max, which are X-ray tube replacement, collimator replacement, X-ray generator repairs, dose adjustment, detector calibration, PACS connectivity issues, software reload, customer training, and so on.
Assalamualaikum warahmatullahi wabarakatuh. Now I will present about safety in fluoroscopy. My name is NUHA binti AZHAR with matrix number 061602. Physicians performing fluoroscopy procedure should be aware of the potential for serious radiation-induced skin injury. Occasionally, there will be an unavoidable consequences of the time required to perform complex procedures. However, some of this can be minimized through a better understanding of how the equipment works and how some operational procedures affect the total skin loss. For the safety in fluoroscopy, we can divide it into two parts. One is for the safety of patients and another one is for the safety of staff when handling the machines. Okay, this is the first part, safety of patients. Firstly, the X-ray tube needs to be positioned under the experiment table. By positioning the X-ray tube below the patient, the amount of scattered radiation that reaches your upper body will decrease. As you can see in the picture, when the X-ray tube is put on top, the radiation will increase on patient and the staff in charge. However, if we put underneath the table, good radiation protection is practiced. Secondly, one of the ways to ensure the safety of patients is by closing the collimators down to irradiate only the region of interest. This will reduce the area and volume of tissue irradiated. It will also improve the image contrast by reducing the amount of radiation which scatters back into the intensified image. Thirdly, when using the C-arm position, HB positions as shown in the picture above. This will reduce skin exposure since the highest scatter component is the scatter reflected from the primary beam. Now I will present the second part in the safety of fluoroscopy, which is the safety for staff. The most important things when handling fluoroscopy is the shielding. Shielding can be one of the protection against the radiation scattered around us. The shielding, such as lid garments, lid cloth, thyroid shields, lidded eyeglasses, lid drapes, and also clear lidded glass barriers between the patient and the operator. Okay, next is the distance between the machines and the operator. The distance should be one step back from the table side because it can reduce staff exposure by the factor of 4. And lastly is the time. Time is also important things to take care of when handling the fluoroscopy. It must be balanced between the productive clinical use of X-rays and minimizing fluoroscopy time to reduce exposure. Okay, here is the list of references used by our group member to search for info for our presentation. I think that's all for our presentation. Thank you and goodbye.